A dilution is where the solution looks lighter each time because the molarity decreases. After weighing out copper sulfide, I add 10 drops of ammonium, which is then completed by adding water to finish the solution. We will do this about 3 times to get 4 different solutions, but before you go to the different solutions, you must know how much of the previous solution you have to use to add to the next one, and by that, to get the correct molarity. And then by that, you needed to know a special formula to use to know how much of the previous solution you needed to take in terms of milliliters to add to the next one. And that's how dilution works, because each time the molarity decreases. And we're going from 0.02 molarities to 0.01 molarity to 0.003 molarity to 0.02 molarity. And the equation for that is M1V1 equals M2V2. And then that's how you determine how much of the previous solution you need to take to add to the next one to get the correct molarity. And here Shaw is teaching me, or the TA is teaching me what the correct equation, how to calculate it to get it.
Is that the one that you were working on?
And that's how dilution works. You do this 3 times, and then at the end you would get 4 solutions. And at the end of 4 solutions, you would then use all of these in the spectrometer to determine their absorbance. And with their absorbance, you'll be able to determine the molarity of the unknown solution, because the 4 solutions, you know the molarity and their absorbance. And then you use a graph to determine that. He's explaining all this to me. And then here, I'm explaining the molarities I went through, and then this is the work I used to determine each milliliters I needed to add from the previous solution to the next one. And then here's all 4 solutions. And these are the results from the spectrometer. And then because of that, I was able to determine the unknown solution's molarity was 0.04.